Good evening. Thank you for joining us. Tonight, I'm going to show you how to make a little, Space Invaders clone thing. Mostly involving these invaders, which are the aliens descending upon you, the player defender, and you can shoot projectiles at them, which can kill them. This is to set you up so that you could make a shmup later on. All the code is available on GitHub for StarJunk. The wiki details how to get started if you want to figure out what you need to download, all the dependencies, and all the tools to do this. Follow those instructions before you begin this video. What I'm going to be discussing is how to actually program the game. So I've already gone ahead and npm installed the code. You'll need to do that as well. Once you've done that, you can just type no build server. That will go ahead and compile your code. Once it is compiled, it will listen for changes and it'll host any change you make onto a server. So usually my development flow is to have a screen over here and a screen over here. So whenever I see my changes, currently there's nothing because I haven't done anything. But as you can see, it built StarJunk. Console.log hello world. Hello world. It just updates whenever you make a change. So you see now there's 2 building StarJunk. And now we'll continue to run in the background. You can just minimize that and do your development. So let's go ahead and copy in some boilerplate for Pixie.js. To use Pixie, you have to first require it. Require pixie.js. And we only have access to Pixie.js because we declared it in our package as a dependency. So when you typed npm install, it read package.json looking for Pixie.js and went ahead and installed it for you. You just have to import it using require, which is Node.js's statement for importing things. We're going to go ahead and set a width and height. In StarJunk, the game you guys will be developing, we're going to use 230 by 130 because that's kind of roughly a 16 by 9 aspect ratio. For this, let's just do half that. We don't need anything quite as big. But we pass that to the renderer, equals pixie.auto-detect renderer. And you can actually declare either a WebGL renderer or a Canvas renderer. They're both 2 different ways of doing 2D rendering in JavaScript. But if you just do auto-detect, they'll pick whichever one's most available for the platform that the player is on, which is handy. You give them the width and the height, which means it's going to define what that region they're rendering is going to be. And also, you can set at the same time a background color. So I went online and I Googled into a hex value that was nice and green, kind of like one of those old school arcade cabinets. Whenever I use Pixie, I always set round pixels equals true because that stops any kind of weird pixel sublitting. We add the renderer component to the DOM by first getting a place in the DOM to put it. The DOM being the HTML. We're looking for a thing with the ID mount. And then we append child the renderer's view. And once we have that, we can start rendering a game. Equals new Pixie container. This is where we're going to keep all of our game elements inside this little container called game. We can say renderer.render game. See what that looks like. It's just a big old green square for us to draw all of our game components. Again, all of this is just boilerplate. If you Google Pixie tutorial, you will find all of this exact same code. So don't be intimidated by all the gobbledygook here. Everything after this, once we set all this junk up, is actual game logic for us to mess around with, which is always a lot more fun than having to deal with Pixie boilerplate. As a matter of note, whenever I have my main root component, I like to be able to access that from the console. If I type game here right now, it's I don't know what game is. If you say window.game, then that attaches it to the window, and then you can type game in here, and then you can see the game component, which is super useful. This down here is the JavaScript console. you can run JavaScript commands and all the like. But most importantly, you can like mess around with if I wanted to change the color or add more components, I can do that here. It's just good for debugging. So other than Pixie, there are a couple other utilities that we need to go ahead and import, including AffLoop equals require AffLoop and Keeb equals require Keeb. Both of which currently aren't in our package.json as dependencies, so we need to go ahead and add them. npm install save. The save keyword, make sure it adds it to the package.json. Keeb and AffLoop. Just gonna go ahead and start downloading those. And after it's properly downloaded them, it's going to attach them to our package.json. So later on, if you ever need to reinstall your dependencies, you have them documented in your project. Yeah. Bam. There they are. Once we have those, we can import them and use them. One of them is the main game loop. Var loop equals new AffLoop. You give that a function, and it'll run that function over and over and over and over. So over here in our localhost, you see it running over and over and over and over and over. And also optionally lets you use a delta. They'll pass in a delta between the delta time between the frames. So between each animation frame, this is the amount of time that's passed in seconds. So 0.015 seconds generally, which is about 60 frames per second. You can use this for monitoring or optimization. You generally want to use it to compensate for movement between frames, so you never have a case where a game is faster or slower on different computers. We can also ever use console.log keeb. Keeb is the other thing we've installed, which is a utility for pulling the state of the keyboard. Is down, and it's a function. You give it a string, which represents a key on the keyboard. You can give it like A, or W, or S, or D, or G. And if you want to do anything weird, you can do like these corner brackets, angle brackets, and put like up or down for the up or down arrow key, space, enter. If we wanted to do W, save. So what is good to know is print false a whole bunch because I'm not holding down the W key. The moment I hit W, it's going to start printing true. And when I let go, it hits false. So true, false, true, false, true. We use this for actually controlling our players in the game. So these are useful. If we move our renderer.render command into our loop, it's now going to be rendering each and every single frame, which is useful. Because now we can add entities and sprites, and as we move them in our game logic model, it'll update automatically because we're re-rendering it each and every frame. And so let's do that. Let's create a new sprite and add it to our game. So var defender, which is going to be our player character, equals new pixie sprite. And Pixie is pretty well documented. If you Google Pixie sprite, it'll come right up. And it'll tell you that you need to give it a texture, Pixie texture, in the constructor. So let's go ahead and get a texture as well. Defender texture equals Pixie texture from image. And we have to give it an image. We give it a path to an image. Images / here's our source folder, here's our images folder, defender. This is what we want it to look like. It's a bit small here, but defender.png. We pass defender texture, and then we add it to the game. Game.add defender, add child, excuse me. Let's see what it looks like. Nothing. I can't get images defender. Ah, I know why. I just gave the path raw. Here, we need to use that same require command. Require. And now I'll actually make sure to import it and then pass it to Pixie. There we go. It printed our defender right up here in the corner. We don't want it in the corner, so let's move it. Defender.position. X equals 10. 20, 30. For now, let's use our our width constant and position it halfway through the screen. Again, width is something that we defined up here as 230 divided by 2, so like 150. You'll notice it isn't actually centered. That's because pixie sprites by default are like positioned by their top left corner. We can change that by the anchor command. Anchor.x equals 0.5, i.e. halfway through. So now he is positioned by the center of his sprite. Let's do the same for defender anchor.y. Let's anchor him from the bottom of his sprite and position him defender.position.y height -2. So he's 2 pixels from the bottom. There we go. That's our little guy. What's really neat is that in our loop, we can change him, defender.position.x ++, for example. Every frame, he's going to move 1 pixel to the right. Whoop, there he goes. If we minus, he's going to go to the left. This is 0, 0. This is 230 divided by 2 by 130 divided by 2. This, so if you ever want to go up, it's negative. If you want to go down, it's positive. If you want to go left, it's negative. If you want to go right, it's positive. And that's normal computer graphics stuff. Let's not move him every single frame. Let's move him only when a player's key is down. So if we said, let's use this command we had here, but instead of logging, we say if key is down D plus plus, and there we go. If I hold my key down, he moves to the right. If I hold the key left, let's make a key for key left. Else if key A minus. Right, left. Woo! Cruising along the screen. Generally, you want to not move in increments without timesing by delta, which is the amount of time between frames. So if I said, if I want to move 20 frames per second, I could just times by delta. So minus equals 20 times delta. So now I'm making sure that I only move relative to the amount of time within each loop, because on some computers, this loop might be run faster, and on some computers it might be run slower. So this way we're making sure we're having a unified experience on all of them. Let's move this to defender.speed, so we're not messing around with magic numbers. Defender.speed equals 20. And we can actually make that, let's make that a bit faster, why not? That's more fun. Let's go back. There we go. So there we go, we got a little defender on the screen. But that's no fun if you have nothing to fight, so let's add the invaders. Again, we have to make sure we have a texture. So let's move our textures up here. We'll put all of our texture importing right up here, and then we'll instantiate them down here. So var invader texture equals pixie texture from image. If use required to make sure to import it, and we give it a path dot images slash, and I have that star junk images invader1.png. Invader1.png. So let's go ahead and create a new sprite. Invader equals new pixie sprite. Invader texture. And I have to make sure we add that to the game. Add child. Invader. He'll appear up here in the corner. There he is. Nice. Now, what's important to note here is that we're going to want to make a lot of invaders, not just one invader. And we're going to have a lot of like special, unique behaviors for them, and want them to encapsulate their own state about like what direction they're moving and how much like damage they've taken and stuff. And to avoid just tacking on more and more properties of pixie.sprite, what's far more valuable here is we went ahead and created a new class. And we can do this with the new JavaScript specifications. So if you go ahead and you say, instead of just invader, right, we went class invader extends pixie sprite. That's right, we're doing inheritance here. Then we can say constructor. If you remember your object-oriented programming, we have to do super and pass what we would put here into pipe we'd usually put into the constructor here. So we want to say invader texture, and then we can say all sorts of junk here. We can put all of our like this dot anchor dot x equals 0, and we can change the manipulate its state by the this keyword. Most importantly, let's say if we said this dot position dot x equals x, x being a value we gave into the constructor of our invader, such that whenever we said invader equals new invader, we could give it like, I want it to be at pixel 10. Save. And now we're rendering our entity from this class that we just defined. So this is super useful, right? We could just say game.add new invader, new invader, new invader. Let's add a whole bunch of invaders, right? Let's put you at 30, you at 50, put you at 70, get like 4 different invaders across the screen. Look at that, an army of invaders here to invade your planet. Of course, we could, instead of just saying this manually, we can do this for loop. So for var x equals 10, let's say x is less than width, which is that predefined constant we made up above here. And then we said x plus equals like 20, such that game.addChild new invader x. We can remove all these. Then we should have a whole line of invaders across the screen. We can mess around with these numbers a bit to get them more snugly on the screen. 5, maybe like, try to center them. There we go. They're kind of centered there. Yeah, yeah. We could do the same thing we did for the invader with the defender. So let's go ahead and do that as an exercise of our encapsulation. Defender extends pixie sprite. Constructor, super defender texture, and then we can take all of this and put it here. We could say find defender, replace it with this. So find, replace. Cool. And instead of saying new pixie sprite, we can just say new defender. We can add that defender to add child. More interestingly, we can also go down here into this behavior we've defined here, and we can say, let's move this into like an update function. We can just say defender.update delta update delta, and the code we put here is now going to be accessed from the main loop as like a subroutine. So, this dot speed. Let's try this. Make sure we didn't break anything. Cool. There we go. So yeah, this is nice because now, like, if we check our game, which we defined before, game.children, we can see all the different, like, classes we defined. We see our 1 defender and our 1, 2, 3, 4, 5, 6 invaders that we have descending upon our planet. And they all have those custom, like, classes and properties that you defined as inherited from the pixie.sprite class. If we, for example, wanted to extend this invader even further and give it its own update function, and then we could iterate through all of the invaders by saying game.children.forEach child.update delta. So now we're going through each and every child that we have here in our array of children, and we're updating it. So we can say this.position.y plus equals math.random times 10, for example, this.speed times delta. And because we encapsulate each of the individual invaders, they all have their own y, they all have their own speed, and they're all descending upon us to kill us. But, of course, they won't actually kill us because we haven't added any code for like a game over state, which is super easy to do. Just here in our update, as we have our decreasing y position, we just say if this.position.y has decreased so much, it's now greater than height, which is our that constant we define for our game frame, minus, let's say, 7. So like around here, abouts. Go ahead and say window.alert, game over. Window.location equals window.location. And what window.alert is like this default JavaScript function that pops up as a little modal. It's that same function that like ad marketing spam uses that pops up a little frame. So don't actually use this in your actual game. Like look how ugly this is from a UI perspective. And then window.location equals window.location should refresh the page. Oh geez, spamming myself. Each of the individual invaders are trying to tell me that I've lost, and then it refreshes the page. That's the true game over state, right? When the invaders invade your planet, they invade you with pop-up windows. I'm gonna go ahead and comment this out during development because this is annoying as heck. But it serves as a good punishment for those who fail to defeat the oncoming invaders. And we have no good way right now of defeating the invaders. Let's go ahead and add that. Let's add projectiles that our defender can shoot at the invaders. So let's create a new class. Class projectile extends pixie sprite. Constructor. Super. We have to give that a texture, right? Projectile texture, which we need to define up here. Var projectile texture equals pixie texture from image require images projectile. There it is. Projectile.png. Projectile.png. Yeah. We could go ahead and like add this to the game.addChild projectile. New projectile, but that wouldn't do us much good. It'd just pop up the little projectile up there in the corner. What we want to do is we want to pass an x to it. This.position.x equals x, and this.position.y equals like height minus 10, because we want it to appear down here at the bottom of the screen where like our defender is, right? Yeah, and once the projectile does appear on the screen, we want it to fly upwards. So let's give it an update function as well, which once it is added to the game, it will be part of this whole game children for each child update loop. This.position.y minus equals this.speed times delta, and we'll make this.speed equal 40. So let's go ahead and instantiate this projectile in the defender class. So whenever the player keyed is down, hits spacebar, and space is again one of those like funky exceptions where it's not like a letter or a number where you just put in A or 1. You have to type in space with the angle brackets. If the player hits spacebar, let's game.addChild new projectile. We want to give it the x, that's our x, this.position.x. So let's see what that does. You see I'm painting a ton of projectiles at once. Those are each an individual projectile, don't be confused. And that's because I'm using isDown instead of just isJustDown. IsJustDown just listens for the first time the key goes down as opposed to every time it's down. So there we go. That's what the projectile is supposed to look like. It's supposed to be a tiny little blip. You'll also notice that even though the projectiles have moved off the screen, they're still totally counted in our game container, which is bad. If I make a whole bunch of projectiles, they'll all still be like trying to update and check for collision and stuff, even when they're way off the screen. So let's add something in our projectile that says if this.position.y is now less than 0, game.removeChild this. So remove myself from it once I leave the screen. Boop, you'll see, and dink, it's gone. So like if I game.child, game.children, boop, you see there's a projectile on the list. Once I refresh it, if I say game.children again, projectile is gone. It's removed itself since it's fallen off the screen. You'll notice that when it hits the top of the screen, like the moment the first pixel touches the top of the screen, it disappears. The best way for us to do this is to say if this dot position is less than negative this dot height. So wait for me to get fully off the screen before you remove me all the way off, and then it disappears. Yeah, so what's important now is that these projectiles actually do something. They're currently harmless to the invaders. We need to do is add a collision between the projectiles and the invaders, which is easy enough to do. What we need to do is add some code here in the projectile so that every frame it searches through the game for each child and checks, and only looks for children that are instances of invaders. If it is an invader, then it checks if it's colliding with that particular invader, which is complicated to do between like rectangular AABB collision. But if we try to boil it down, we could say if child.position, if the position of the invader, dot y minus this dot position dot y is less than this dot height and math dot absolute child position x minus this dot position dot x is less than child dot width. And we have to plus 0.5 because the invaders has an anchor of 0.5. If that is the case, if it is true that we are colliding with the invader, then game.remove the invader. Let's see if that works. I don't know. We'll see. Wink. Yeah. Boink. Boink. Oh, near. Grazed him. Oh, I'm still gonna lose though. I wasn't able to stop those invaders. But yeah, currently our projectile shoots right through the invaders. Let's remove child this as well, which removes the projectile. That's the projectile. So that whenever it hits a invader, it'll still take them out. Boink. Here we go. Boink, boink, boink. Ta-da! Yeah. One last thing before we finish for tonight. I want to add a boss monster, such that if you beat all the monsters, if you do remove a monster, if you do remove an invader, let's say if game.children.length equal 1. So if you removed a entity from the game and you're the only entity standing, there's only one entity left and that's you. And if, let's say, like game.hasSeen boss is false, that's what the little exclamation mark means, set game.hasSeen boss to true, and game.addChild new boss invader. Yeah. We're gonna make the boss invader class. Like let's put right here next under the invader class boss invader, and instead of extending pixie.sprite, let's just go ahead and like extend invader. So we're reusing all the code we have here. It's the exact same constructor and everything. All we want to really do is constructor super. We have to give it an x. So let's say width divide by 2, so it's centered. Let's say this dot scale dot x times equal 4, and this dot scale dot y times equal 4. It's gonna make it 4 times as big as any other invader. I think that should do it. Let's see. Oh no, I got an error. This is what an error looks like, by the way, a compile time error. It pops up this. The same error is also in the console, but hopefully you never look at that. I'll just write it right to the browser as well. Oh, I misspelled extends. That's just extend. This is what syntax highlighting is really useful for. Once I finish extends, it becomes purple, which is an actual keyword. Let's see here. Oh, the suspense is killing me. Boo, boo, boo. Oh, am I gonna make it? Boo. Dude, ding. There it is. Oh, look at that monstrosity. I'm sure there's some way in Pixie to fix that so like it scales properly, but I'm tired. It's late. That's the boss monster, and once you finish that, you beat the game. Um, we should simply add another alert such that if the child you just removed is an instance of boss invader, window.alert, you've won. And that way we have some closure on our game. We have a defender who moves around. We have invaders that descend from the heavens. We have projectiles that shoot the invaders. We have collision. We have wind and lose states. We have a finished game, which is super nice. Let's uncomment our lose code. All of this I'm going to make available on Git. So let's quit our server. Hit Control-C to quit the server at any time. It no longer hosts the server, so you have to refresh the page. It's gone now. But Git status. I changed 2 files. The package.json, we included 2 files, and we put all of our code into index.js. And all your actual code, you shouldn't make it one long file. You should split into subfiles, especially if you're working on a team. But git add all, git commit message, built space invaders, git branch. I'm on the getting started branch. Git push, origin, getting started. And that way you'll have all my code up on Getting Started so you guys can see what I built. Most importantly though, we also have this cool little script I made here called share, which basically just builds it and uploads it to GitHub pages. So if you just say share .sh, share chmod plus x share share.sh, and you have to give it a number. So let's just say let's give it a tag. Like you can usually say viewpoint 141 or whatever like that. Just say invaders. If you give that a name that's already been used, like I said invaders, you just say name yourself something else. That way you won't overwrite mine. It's basically downloading it, it's building it, it's pushing it up online, and once it's all done, we can be able to go online and show it and share it with our friends. Yeah. The takeaway from all of this, of all the things we've built here, is that what you need to build now, if you wanted to create a shmup, isn't all that different. Like, you just need to make it such that the monsters, the enemies, aren't coming from the top, they're coming from the side. You probably need to make it a bit more juicier when you shoot things and they explode, and have some stars in the background, maybe different power-ups. But really, other than that, the basic core gameplay of winning, losing, shooting stuff, and losing is all there. So, yeah. Once you finish your game, it'll be hosted on moxarcade.github.io/starjunk, and then whatever tag name you gave it. So you can go ahead and give this to your friends. Look at that. Yeah. This is online right now. So once you guys finish this, I want you to go to the Slack and share it with me. That's what I want you to do. I want you to copy it in, paste it there, hit enter, so everyone can see your version of the code. I'd love to see that. So yeah, I'm going to go ahead and edit this together and upload it and give it to you guys so you can start working through it. Please reach out to me if you have any questions, and I hope this helped. Have a good night. Bye.